The function f is defined by this arrangement, this expression here, for x bigger than a half. Show that f of x is 1 over 2x minus 1. Find the inverse function f of x. Find the domain of the inverse function. G of x equals log of x plus 1. Find the solution f of g of x equals 1/7, giving your answer in terms of e. So let's have a look at this then. I've got the question in summary form here. So let's look at this first, f of x. So let's tidy that up then. So part A, so f of x then is equal to, let's cross multiply the fraction. So it's 3 x plus 1 times the x plus 4 minus 1 lot of, and this stuff here needs moving up to here, doesn't it? So it's 2x squared plus 7x minus 4 all over these two times together, x plus 4 times 2x squared plus 7x minus 4. So let's try and tidy this up then. What have we got here? Okay, we've got x squared, and there's 3 lots of, so that's 3x squared. Then we've got 4 and 1, so that's 5x times 3 is 15 lots of x. 1's 4 is 4, times the 3 is 12, minus the 2x squared, minus the 7x, minus times a minus is a plus, so it's plus 4, all over this times this, which is x plus 4, and we can factorize this here, hopefully 2x and x has got to be, and the 4 would be 4 ones to make a difference. If we put 4 here, we can see the difference will be 7 if that's a plus and that's a minus. 2x squared, 8 minus 1, which is 7, and then minus 4 here. So on the top, 3x take 2x squared is just an x squared. And then it's 15 take 7 is plus 8x. And then we've got 12 plus 4 is 16. So that's that. Over x plus 4 squared times 2x minus 1. So that's equal to, the top bit is x plus 4 squared, that's easy to see. And then we've got an x plus 4 squared underneath, haven't we? And then the 2x minus 1. So that's equal to 1 over 2x minus 1, which is what we wanted to show. Okay, there's the function f. Now find the inverse. So part B, so y is equal to 1 over 2x minus 1. Bring these terms here from underneath to the times on top. And at the same time move the y down to be underneath. That tells us then that 2x, move the 1 over, 1 plus 1 over y. So that tells us what x equals now. Divide by 2 all the way through. Half, or move the 2 from times down to divide, plus 1 over 2y on the other side. So the inverse function now then, so f minus 1 of x is equal to 1 over 2 plus 1 over 2x, isn't it? Just swap the symbols. So there's our inverse function for part B. Now part C, find the domain. Domain of f minus 1 is the range of f. C, domain f minus 1 is equal to the range of f, which equals 2. Okay, the range of f then. Here's the function f here. So if we look at this, it's only valid for x is bigger than a half. I'm just going to do a little sketch of it. This is asymptotic because it's 0. The denominator is 0 at half. So it shoots off to infinity. Slightly bigger than a half, and this will be small positive. 1 over small positive is large positive. And when x is, say, 1,000, this will be large positive. 1 over large positive is very small. So it's going to come down from infinity down to here and tend towards 0, isn't it? For x is bigger than a half. So we can see that range of f then is just simply the set from 0 to infinity. i.e. x bigger than naught. All the positives but not including 0. Okay, so that's C. Now part D. Find the solution f g of x is 1/7. So D. So f at g of x, which is equal to f of g of x, and g of x was equal to log of, where was it, x plus 1, so it's f of ln x plus 1, and f is 1 over 2x minus 1, isn't it? So it's 1 over 2 times the something minus the 1 equals 1/7. So let's rearrange it then. Move the 7 up here. 7 is equal to, and move this stuff that's underneath here up to be with the 1. Minus 1. So read from right to left then. 2 log n of x plus 1. Move the 1 over to be with the 7 to make 8. And that tells us that ln x plus 1 is equal to 8 over 2. Move the 2 down, which is 4. Unwrap the log. X plus 1 then is equal to the log base e swings up, hits that in the air, e to the 4, and finally we can write x is equal to e to the 4, move the 1 over to minus 1, e to the 4 minus 1.